So the current drugs that are used to treat Alzheimer's disease are really kind of first generation situations here. We know that with Alzheimer's disease, we see a reduction of acetylcholine, but unfortunately, this is at the very end of the pathophysiological phenomenon of Alzheimer's disease, and they really don't work terribly well. They work really at the end point. That's why it's often recommended that if you have somebody newly diagnosed, they're put on these products because this might stop some of the deterioration. So if you remember back as far as what happens with synapses, how do we form acetylcholine? An acetyl group combines with a choline group, and it's synthesized, it's stored in vesicles, it's released, it binds, and it causes EPSBs to happen. We find that when people have Alzheimer's disease, there's less acetylcholine. So the idea of these products, acetylcholine is broken down mostly by enzymes, mostly by acetylcholinesterase. And so the main products, Aricept, Exelon, and Razidine, basically work to block the enzyme acetylcholinesterase from destroying acetylcholine. So they help keep acetylcholine in there more. They're considered acetylcholinesterase inhibitors, so thus they're considered agonists and will increase acetylcholine. You can see one of the clinical trials going on with Aricept, Donepezil, that it did increase Alzheimer's progress. They had a study group doing this. They were paid by the drug company to kind of go about doing this, but they did get FDA approval. The other product that has come out more recently is a product that it also appears that there's too much glutamate working when somebody has Alzheimer's disease. So memantine, the name of the product is called Namenda. Namenda standing for name because glutamate binds at the NMDA receptor for glutamate, and memantine is also used, and now they even have a combination pill because glutamate is working in a different way than that. So these are the current treatments out there, but they really haven't been that good. So if I was to ask you what would work, if you go all the way back to the first part of the pathophysiology lecture, the idea is it was that amyloid precursor protein, and it was that being cleaved by beta and gamma secretase. So you'd want to actually start by blocking that process. But the 29 research centers I put under hopeful here, Merck recently came out with something called MK8931, and in phases 1 and 2 of the clinical trials, it looked like it was working just great. It was blocking gamma secretase in this particular situation. Was it beta secretase? Sorry about that. Yeah, it was blocking beta secretase from forming, and it seemed to be working. But then when they went to the phase 3 clinical trials, it ended up being no more effective than some of the other products out there. So they're recalibrating this. They thought they used some wrong people, but MK8931 blocks the beta secretase from being cut, and that would seem to be useful. So we're still hopeful about that one. A lot of other things have been tried and failed. They had a lot of products that seem to try to reduce amyloid plaques from forming in the brain, but if you read on number 4, they tried this, but they had to pull the plug on phase 2 clinical trials because it just didn't look useful. So it shows that. Aspirin, there's been a lot of work on can aspirin and anti-inflammatories actually help, but once again the Cochrane review put out a few years ago suggested that no, it doesn't really appear to work. The statins, they're another idea, but they don't seem to work either. It was thought that estrogen might be helpful. So the Women's Health Initiative study on one of the pages of your abstracts talks about this. They had to pull the plug on that because they found that when they gave it, it actually made it worse. So estrogen doesn't appear to work. The next abstract is on statins. We thought that might be good because it seemed that people who were on statins seem to have a lower risk. Statins are related to apolipoprotein E4, which is also related to LDL, low density lipoprotein, and heart disease. So it was thought that if you give people statins, maybe this would help people out. But once again, tried and tested, and it didn't seem to be borne out. Vitamin E, alternative medicines, Cochrane database review, doesn't look like it's useful. This might go under some of the PNI stuff because it's alternative medicine being done here. So that doesn't appear to be useful either. And even ginkgo biloba, once again, the research with the Cochrane review doesn't seem to be effective. So we're still a ways away. Pharmaceutical companies are working on all these things, but right now we know that it does have a human toll. It can get very expensive. You watch your family members deteriorate with this disease. Probably the most famous person to get this disease was President Ronald Reagan. At one point, Nancy Reagan, his optimistic wife, made a statement like, we're riding into the sunset and we're going to cope with this thing as well as possible. The New York Times had a sentiment when they found out about this saying he's now going into the terrible disease of Alzheimer's and he'll never escape from it. Our society does not really know how to cope with our own mortality. Alzheimer's disease brings that into the forefront. We do have these 29 research centers doing lots of good work. They come up with a yearly report on the progress they've made. They fall into the categories of predicting who's going to get it. Can we actually look and predict? Can we actually do something to stop it? What about the social support and the families? And but we're still a long ways away from getting to where we need to be. So that's the summary of Alzheimer's disease. Thanks. Bye-bye.